Welcome, algebra class. This is your first screencast, so happy Friday. Welcome. I'm glad you found the link on Final Site. You'll need to go back to Final Site later in the class for another video to watch. So the sub should have give you a beige sheet of paper, so that's all you need out. You need that and a pencil. You might want to grab a calculator. Remember, they're in the back of the class or on the side of the class, depending on what room you're in. So try to put your phone away for this. Make sure your phone's not out. I want your focus just on this. So today's agenda, screencast with notes. That's using that beige piece of paper. Then you're going to have a YouTube video with some questions. You're going to answer that on a separate piece of paper, or you can answer it on that beige piece of paper. Just be careful. There's not that much room. Then you're going to be given a white note worksheet. That's going to be collected at the end of class. So if you don't finish it, that's not homework. But it will be graded, so I want to see how much work you put in during class while I was away. So I'm going to look at that sheet, see if you put in good effort for the day, and give you a grade. And then, like I said, no homework over the weekend. Enjoy your weekend. Should be nice out. But I will be back Monday, bright and early at 6:30, and we'll be leaving at 12. So period 3, you have the luxury of seeing me. But period 5, unfortunately, you'll have to do a screencast again. I think they're pretty cool, but you don't get to see me in person, unfortunately. I know you're dreading it. But, so, without further ado, let's dive in. So, again, have that base sheet out, piece of paper. You should have read the top already. So, just want to point something out. When it gets to italicized letters, so right down here, you have some italicized letters. That's where you need to pause the video. I will remind you, but pause the video. Answer the question, maybe talk to a friend, take 1 or 2 minutes to jot some stuff down. Like for this one, you're going to have to think a little bit, and down here, you're going to have to write explicit rules. So take some time, pause the video, and then when you're ready, come back. So first question for you. How would you describe it? When I say it, I mean arithmetic. How would you describe the word arithmetic? If you wanted to explain it to somebody, how would you go about explaining to them? So go ahead, pause the video, and write some things down. All right, so welcome back. Should have took about a minute to do that. I'm going to give you the definition, and I've given you this definition about 3 times now. So, a sequence that increases by a common, increases or decreases, so it can go up or down the sequence, by common difference. And remember that common difference, that's how it's changing. How is the pattern changing? Is it going up by 3, down by 3? It needs to be the same thing every time, and we're going to introduce what it looks like when you're not adding or subtracting today. That's the new thing you're going to be learning. All right, sorry about that. So we have to, my roommate being a little obnoxious in the background. So the next thing you have to do, I also didn't mention, welcome to my home. This is the one time you'll be in my home. You'll just see the beige wall behind me. Not going to give you a tour, sorry. So we're going to jump right into the next thing. So a lot of people have been struggling with this, and a lot of people are doing really well with it. So I want you to try your best. Try to write the explicit rule for the following. Just as a heads up, you have 28 here on your paper. I need you to change that to 26. That's a mistake on my part. So when you're writing the explicit rule for a sequence, remember this is the first term. So if you're trying to use A0, you have to find A0 by working backwards. And this is a table, you're given A0 right there. Real quick before you dive in and trying that problem out, remember our formula. So our formula is f of n equals a0 plus dn. Remember a0 is the 0 term, and d is our common difference. Sorry, this doesn't really look like a 0. So that's a0. It still doesn't look like a 0, but try my best. So, and then remember our other one is f of n equals a1 plus d times n minus 1. So that's a little trickier, n minus 1. So as I mentioned last class, pick one. Pick whichever one works for you. If you like a sub 0 plus dn, just use that every time. If you like a sub 1 plus dn n minus 1, use that. It's really up to you which formula you want to use. So go ahead, pause the video, take 2 to 3 minutes. If you need more, use that time. But try to write the explicit rule. Try your best. Now go ahead. Okay, welcome back. So you should have tried to do the explicit rule. I'm going to give it to you now. So let's get down here. So my equation for number 1 is f of n equals 5 plus 7n. Now you're probably wondering, it's 5. How did you get 5? If you didn't get 5, it's because you use this first term. This is a sub 1. You need to work backwards. So what's happening here? Well, we're increasing. This is plus 7. Now, I need to work backwards. That's minus 7. Minus 7. So 12 minus 7 is 5. So we're starting at 5, adding 7 every time. Plus 7, plus 7, plus 7. If I wanted to find the 20th term, I'm just adding 7 20 times. That's how this equation works. Now, for number 2, I'm going to type it right down here. You're given A0. And luckily, it's 0. Your calories burned is 0. So your f of n equals 0 plus d. What's my d here? Well, I'm adding 298 n. Again, you don't have to write the 0. You could just do f of n equals 298n. That's the exact same thing. Both work for solving for any nth term. So that is just review. That first 2 notes were just review. That's everything we've learned up to now. We've just focused on arithmetic sequences. So let's move on to something new. So what I want you to do is take a look at these 2 sequences. You have this one. Something's happening here. It's increasing, obviously, but you need to figure out what it's increasing by. And then something's different is happening with number 2. So what I want you to do, take a look at the common differences, see what you can find out, and then write something down here. What are some differences between the 2? You can write some similarities too if you want to write that, but I really want you to focus on the differences. So go ahead and pause the video. Okay, so for number 1, it's increasing by 3 every term. Adding 4. Increasing by 4 every term. And again, if I'm going too fast for you, luckily you have a video, you get to pause it, you get to go back, rewind, ask your friend, hey, did you get to this part yet? I'm not sure what he's saying there. So I apologize if I am confusing, but the nice thing with the video is you get to go back and redo it and rehear it. So number 2 now, it's not increasing by something the same time. Because if you see from 3 to 6, we're adding 3. But from 6 to 12, we're adding 6. So there's no common difference here. There's no increase by blank every term. So what we have to say here is if you look, this is times 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 24 is 12 times 2 is 24. So we're actually multiplying by 2 every term. So we take the previous term, multiply it by 2, that's how you get the new term. So this one's going to be increasing a lot faster. That would be a difference. This one's increasing by the same thing. This one's increasing really fast. Think about how big the next term is going to be. It's going to be 48. Then from there, we're going to get even bigger to 96. So we're getting bigger, bigger, bigger really fast. This one takes a long time. It's going up by the same thing every single time. So what do we call sequences by like number 2? Flip over to your back of your sheet. We call them geometric. So a geometric sequence, I'll give you the definition, is a sequence that increases or decreases by a common multiplier. If you see below, we sometimes say common ratio. Some teachers will use ratio, some teachers will use multiplier. We're going to use multiplier in our class just to talk about how it is increasing. So if I ask you how is the sequence increasing, what is the common multiplier, you'll know what it is. I'm going to try to rarely use common ratio, but we'll talk about it just in case you're working with a friend or something like that. He's talking about the common ratio, someone from another class. It's the same thing. So what is it? So the common multiplier is what is being multiplied between each term. And so how do we figure that out? So this one was easy. You could probably see that it was times 2. But if you didn't know how to do it, we just take the second term. We divide it by the first term, and that equals our common multiplier. Make that a little bigger so you can see it. So up above, 6 divided by 3 is 2. 12 divided by 6 is 2. So we just take our second term divided by the first. That's how you find your common multiplier. That's important because we need to know what's happening between each term. Now we have some examples. I'm going to do the first one with you, and then you can do the second one on your own, and we'll go over it. So the first one. First, you always want to assume everything's arithmetic. It's the easiest thing. See if it's adding or subtracting by the same thing every time. So to get from 12 to 36, you add 14. Nope, try that again. 24. So you add 24. Now, if we add 24 again, that's not 108. Definitely not 108. That's only 60. So it's not arithmetic. So as soon as it's not arithmetic, you try the next thing, geometric. We'll see if it's multiplying. How do you get from 12 to 36? So if you can't figure that out in your head, you can always take the second term divided by the first. So let's do that. Let's do 36 divided by 12. That's going to equal 3. Or you can say 3 over 1. How did I get 3 over 1? Well, you can plug it into a calculator. It's probably the easiest thing to do. Or you can just reduce fractions. How many times does 12 go into 36? 3 times. Or you could have done 6. How many times does 36? How many times does 6 go into 36? Well, 6 times. How many times does 6 go into 12? Well, that's 2. Oh. And 6 divided by 2 is 3. So our common multiplier, that's all I want you to find for these examples. What is the common multiplier? So go ahead, pause the video, and try number 2. So for number 2, you should have got your common multiplier is 1/2. Now, what a lot of people did is they probably saw that it was dividing by 2. So they just said, well, my common multiplier is dividing by 2. But the word multiplier means multiply. We only talk about multiplication. What's the same way as saying divided by 2? 1/2. You could do that. You could do 20, the second term. 20 divided by 40 is 0.5. You could also say it is 0.5. If you don't want to say 1/2, you just say 0.5. They're the same thing. So we only do multiplication. So real quick, pause the video again. Determine if the following sequences are arithmetic or geometric, and find their common difference or multiplier. Go ahead, pause the video, and try that out. All right, so the last thing on your sheet, these last 2 problems, you should have got the first one's arithmetic. It's increasing by 7, or my common difference, well, I can't spell. My common difference is 7. Now, for the second one, you should have got it's geometric. Again, try to see if it's arithmetic first. We're adding 7 between 2 and 10. Not adding 7, adding 8. 10 plus 8 is not 50. So you know it's geometric. You do the second term divided by the first. You're going to get, so geometric. Well, I'm bold here. Geometric and multiply. Multiply by 5. Well, my common multiplier is 5. So that's the end of the video. Thanks for following along. Now, look at the bottom of your sheet. You have some directions where you need to go next. You need to go onto Final Site, watch that video, and then again, answer those 2 questions on a separate piece of paper or on this piece of paper. Once you finish that video, you can go ahead and get the worksheet from the sub, or he or she might have already given it to you. It's a white piece of paper. Do that, hand that in at the end of class, and enjoy your weekend. If you're period 3, I'll see you Monday. Period 5, I will see you Tuesday. Have a good one. Bye, guys.